Welcome back. Welcome back to the third block of IDEA StatiCa Global User Day. Topic of this session is what's new in the best material, concrete. I'm very happy that I have four esteemed panelists to discuss this with me, so allow me to introduce them to you. So starting from the left, Lukáš Bobek, hello.
Hello.
What do you do?
I make a cappuccino for my colleagues, but in the meantime, I work as a product owner for concrete applications, which means that I'm responsible for the implementation of the code into our application and the features implemented in them.
Thank you. Tomáš Svoboda, hello.
Hello.
What's your job?
Well, I am a product engineer in IDEA StatiCa. So I'm part of the customer care team. So I'm here for you to help you with structural engineering issues, especially in concrete.
Thank you. We got Joris van der Loo. Hello.
Hello.
What do you do for a living?
I'm a structural engineer at Snijders Ingenieursgroep, based in Veldhoven, the Netherlands.
Okay, thank you very much. And Jakub Geringer, hello.
Hello, I'm bridge engineer in Studio Praha in Czech Republic. It's a multi-branch company.
Very good. So we got a mix of colleagues from IDEA StatiCa and customers from the structural engineering field. I would now like to ask Lukáš to share the highlights of version 23 for concrete in our first presentation.
Hello. My name is Lukáš Bobek, and it's a pleasure to be here to introduce you what is new in a concrete. Let's start with the new features implemented in version 23. We did a great job with our detail application. Limited stress check allows us to get rid of stress peaks in structures with sharp corners. This is a code-compliant approach, and thanks to it, you can get satisfactory code check for walls with openings. For those who deal with pre-stressing, we implemented long-term losses for detail applications. We know that it's very important to capture the behavior of the structure in lifetime. So now you can get all the code checks such as a crack width, deformation, and much more according to your code also in lifetime of the structure. Because we want to push our application detail for all the market over the world, we need to localize it. We did a great job with the ACI localization, but it's not just about the implementation of ACI Designer's Code itself, but it's about the units and much more. Later, my colleague Tomáš will tell more about each of them. I want to say also that we work a lot on our 3D solution, which is not released yet, but who is interested in can write to our chat and can be downloaded in a beta version on 23.1. What is our position with the concrete apps in the market? Actually, it's the same as with steel. There is a lot of global software all over the world who do the global analysis. We don't want to compete with them. Actually, we want to cooperate with them. So we want to take the part of structure, the reinforcement, internal forces, and do all the code checks. We can code check discontinuity regions, cross sections, critical members, and much more. Because the connection is the most successful application, we want to follow its path with our concrete apps. The detail application is basically the same as the connection, but it's suitable for concrete. So it means you can define any geometry of the structure, any loading, any reinforcement layout, and then do the code check according to Eurocode. If you deal with the slender columns or some kind of stability problems, critical members, fire design, the member application will do everything for you. Of course, it is important to cooperate with other software. So beam links are also very important, and we are doing a lot of work on it. Because there is a wide variety of civil engineers dealing with concrete structures, we want to offer the solution for all of them. RC buildings engineers, they, for example, deal with discontinuity regions such as a wall with openings and stuff like that. But it's sometimes very tedious and time-consuming, so our detail application can cover it. Also, precasters or bridge engineers, they don't do just sectional code check, but many kind of different code checks. And thanks to our applications, we cover everything what they need. Let's show what we do, in fact. Every structural engineers deal with section code check. Our RCS application is the best solution for you. It's not suitable just for very simple cross sections made of reinforced concrete, but we can do the code checks for pre-stressed concrete, for composite sections, and for different kind of very difficult sections used in bridge engineering. Then, when we are looking at bridges, we have a different kind of discontinuity regions, such as the diaphragms or stuff like that. And thanks to our detail application, we are able to do the code checks for all of these very complicated structural parts. Then you get results according to Eurocode, such as a crack width, deformation, etc. Detail application is not suitable just for bridge engineers, but for every engineer who is designing the beam with openings, depth ends, etc. We are offering also the tools which are helpful for the reinforcement design, because sometimes it's quite difficult to define where the reinforcement could be placed. Our topology optimization will help you. Then, regarding the building design, today is the pressure to save the material and optimize the structure. It leads to design of very slender structures, and we know that the current code is not very good for very slender columns because it could be unsafe. Thanks to our geometrically and material nonlinear analysis implemented into member application, you can get safe and good results for your structure. You can look at the deformation, at the stresses, and have a code check according to Eurocode. So that's it. Now I want to know what you do in a concrete design. Let's have a poll.
Thank you for voting. The results are coming in. Reinforced concrete structures, over 60% of you do that most often. We see some of the bridge engineers connected as well. Other types, precast, very good. Lukáš, how big of a surprise is this to you?
It's not a surprise, but it's great news for me, because for reinforced concrete structures, actually we offer the solution for all type of structural members. So, and now we are working on a 3D, so which will be also suitable for the reinforced concrete. So it's great news for me.
Okay, Jakub, what do you design and not design?
Well, I usually design the concrete bridges, so I'm a little bit disappointed about the percentage in the poll. Yeah, but the concrete bridge is also a reinforced concrete structure sometimes, so maybe it's okay.
Very good, very good. We talked a lot about StatiCa Detail. I'm curious, where does it fit in the workflows of a structural engineer, Tomáš?
Yes, well, actually, it has been partially shown in the previous presentation. Every structural engineer needs a CAD software to model or to draw his structure, and kind of software for global analysis, but that's not our focus. The detail application is focused mainly for D regions, I mean for details, for the discontinuity regions, which are usually complicated and which needs like more proper calculations and more complicated ones. But we are offering a solution which is very simple to use and very advanced.
Joris, your ideas of the concrete workflows?
Yes, we are specialized in precast concrete, so we tend to use the Detail app for our connections in those DD regions. Yes, so there it's very handy.
Okay. And if I'm an engineer and I would like to know 3 most relevant things I should calculate with StatiCa Detail, what would that be?
Regarding the RC building engineers, for example, imagine that you have a multi-story building and there is a stiffening core in it. So then you can select the wall from the core, subject it with the load on the edges and do the code check. You will get the results of non-linear deformation of the crack width of everything. So the current methodology defining the codes is not able to do it. Then, for example, if I am a bridge engineer, I have a bridge diaphragm, deviators, maybe pile caps, pier caps, stuff like that, and everything can be designed using the Detail application.
Is it true?
Yeah, it's true. I think even the concrete hinges, etc., it can be done in the Detail. So yeah.
Joris, any other typical tasks engineers might struggle, or you see struggle?
Well, it's quite handy if you are having a deep beam calculation, for example. That's the other where we use it mainly for, I guess. Yeah.
Okay. Lukáš, you got your wish. You got the question about the 3D concrete. So tell us a little bit what's going on.
Okay, so regarding 3D, I have to say that the first version is already developed, but because it's not verified by the universities and it's very important for us to provide customers a verified solution, it will be released in a beta version 23.1. In the autumn or by the end of the summer, hopefully it will be verified by the ETH University in Zurich, and then it will be released publicly for users. So no worry, it will be soon, and you can use it actually in a few weeks. You can try it.
Thank you very much. Another question from the audience. What material model is used for ULS and SLS calculations? Do we know to which application is that pointing?
Yes. Actually, this is a very general question, but I can answer it because we use the similar material models in all applications. For the code checks. So regarding the RCS member application and the Detail application, speaking of the concrete, for the ULS application, we support nonlinear, parabola, rectangular, or bilinear stress strain diagram. Is similar also for steel. And then for the SLS calculation, the stress strain diagram for concrete is simplified, is a linear diagram because it's defined by the Eurocode.
And what checks you would highlight that are there that are usually neglected in Excel spreadsheets or simplified software?
Well, in general, for the discontinuity regions, for the walls, for the corbels, or all structures which are code-checked using strand ties, it is not possible to calculate the deformation of the structure. It's not possible to calculate crack width, but it's very important to know what is happening with the structure. Because you need to secure that during the lifetime there will be no damage by the corrosion of reinforcement, etc. So the Detail can do everything, but it can do it in a short time, in a minute. Using strand and tie is very tedious and time-consuming. And what is more important, every engineer provides you different results because he can create different strand and tie model for the same structure.
The cracks, is it something engineers struggle with?
Yes. Yes, in tie and strut models, definitely, yes.
Your experience?
Yeah, the problem is that it's not something you can calculate quickly or extra properly. So it's okay to have a software to do it for yourself because there's so much variables in the calculation.
Thank you very much. We have one question about the BIM. Let's leave it after the second presentation because we're going to open that topic. So now I would like to ask Tomáš to tell us a little bit more about the features of version 23 for concrete. Let's see it.
ladies and gentlemen, I'm going to present a news in Concrete in version 23. Let's start with the first one, which is about the long-term losses. We have added an option to set an estimation of long-term losses directly into the application. It basically means that you don't have to create and calculate special combinations for long-term and short-term behavior anymore. We have also added a useful tooltips that will tell you what loss for what type of tendons have to be input or what stress should be input. You probably know that, for example, for pretension wires or tendons, you have to input stress just after the release, and for post-tension tendons, you should input, for example, anchorage stress or stress after short-term losses. But this feature is not only about one cell we have added. It has consequences, it influences results. So if you want to learn more about it, I can recommend you to read the release notes on our webpage. Let's have a look at it in the video, how it looks in the application. We have a beam with openings with 3 rows of pre-tensioned wires, and we can see the useful tooltips as I mentioned, and the place where you can input the estimation of long-term losses in the application. If we are going to see the results, you can get the application to display 2 types of stress in tendons. The first type is for short-term behavior and the second is for long-term behavior. And the important thing is that both of them are just only for one combination. So it basically means that you don't have to create a special combination for long-term and short-term behavior. And there is the third stress that you can display in the application, is the stress for ULS. This one is different, and it's mainly because for ULS calculations, we use a different material model for calculation for concrete. And once you are satisfied with your results, you can get the application to automatically create a report for you. Have you ever seen a stress peak in your model? I'm sure that you have. It is a common issue that usually occurs in the sharp corners. The important thing is that it is partially a mathematical issue. It's not a real behavior of a structure. Yes, I know there is a stress concentration in a sharp corner, but this peak, you can simply neglect the peak. And the limited stress check is a functionality we have implemented to give the user an option to neglect the stress peak. These stress peaks are usually in a small areas, so there is no problem to exclude this area from your check. If you decide to use the feature, you will obtain a satisfactory check for serviceability limit state. The application will trim the stress peak and present the modified check in the report with an explanation. You can even display a figure with neglected regions. And there is another video where I would like to show you how it looks in the application. So we have a high wall with 2 openings, and we can see that there is an unsatisfactory check in a sharp corner. So what we can do, we can observe how big is the area and turn on the limited stress check to neglect this stress peak. After we do it, we can see the satisfactory check, and we can even display the neglected regions to be sure that our neglected area is small and it is okay. And after that, if you are satisfied, you can again create an automatic report in the application, included the limited stress check and the neglected areas. And the important thing is the explanation of the situation in non-conformity. Another improvement in detail application is the fully localized environment for ACI users. It means, for example, that we have added a new system of rounding of new entities for imperial units. You can see it in a figure. So on the left side, you can see the old version. There is a cross-section created in imperial units, and on the right side, you can see the same cross-section created in a new version with nicely rounded units. And there is more. We have, for example, added a new templates, including the detailing rules for ACI, new materials, etc. In the last video of the presentation, I would like to show you the whole modeling process of a walking column, which is a typical detail or discontinuity region in United States. In the past, the structural engineer in United States had to create a StatiCa model or do some linear calculations. You may know that the StatiCa is very time consuming, and you can always assess the ultimate limit state or strength check, and the linear analysis, it's not so proper. So you may have noticed that all of the modeling processes or all of the inputtings are done in imperial units, in imperial environment according to the ACI. Here we can see the result of topology optimization, which can be the basement for our reinforcement design, which is again according to the ACI. You can, for example, see the anchorage types, which are brand new according to the ACI. And once we are satisfied with our structure, we can go to the result, go through them one by one, strength check, crack check, diffraction if you need. You can get the program to display reactions to the settings, and again, create an automatic report. And there is more. For the detail application, we have included the transition length for pretension wires in serviceability limit states. It's actually another feature that helps you to avoid the stress peaks. It's because the stress is not applied in one point in the model anymore. It is applied gradually through the transition length. And finally, we have started implementing detail into our BIM-Link portfolio in version 23. You can import your model from SIA, RFEM, or Axis VM by using SAF file to the checkbot, then pick your favorite 2D element and send it to the detail application, reinforce and code check. We haven't forgotten about our other application, so enough about detail. We have also improved, for example, beam application, auto calculation of equivalent time for deflection has been added. A brand new triangular mesh has been implemented to member application. It will be faster and more precise. As you can see on a picture, the old mesh was a rectangular and the integration point was in the center of the rectangle. And the new mesh is triangular with integration points which can be placed on a edge of the cross section, which is more precise. And still there is more. Please read the release notes to find out more. And that's all from my side. Thank you for listening. And now there's time for another poll. And the question is, what is the most impactful feature for you?
Thank you for doing another poll. We can see the results coming in. There's a struggle for the first place between limited stress check feature in detail and implementation of long-term losses. Give it a few more seconds so we can declare a winner. Third place, improvements for ACI. Fourth, faster meshing. Fifth, equivalent time for long-term deflection in beam. Limited stress check feature in detail, the winner. Lukáš, did the most expensive feature win?
No.
It's the second time today.
Is the short answer no? Actually, the most expensive was the improvements or the adaptation for the ACI, like for the US market, in fact, because it's not just about the implementation of the ACI 31819 code, but it's about the improvement of environment, of the units, new templates, and much more.
Okay. Joris, what is your favorite feature out of this?
Well, I was doubting between the first two options, but I went eventually for the one that won. Yeah, the limited stress check feature.
And
Yeah.
why?
Well, because the guys doing the checks or the city council doing the checks potentially are asking questions about that stress exceeding, and now you can get rid of that question
Very
in that
good.
sense. Yeah.
Jakub, your favorite feature?
Well, usually it's faster meshing because it do the work faster. But I like the limited stress check feature as well. But I'm a little bit curious about, is it a gadget to get the satisfactory result in one click, or does it have some redistribution of the force of the neglected area? It's
Tomáš,
May I
Lukáš?
answer? Yeah. May I answer? Okay. I'm going to do it because I like the question. Well, there is no redistribution. This is only about trimming of the stress peaks. I was not mentioned that the pure reason for the stress peaks is the material model which is used for SLS calculation. It's a linear model, as it was mentioned in the first presentation, and that's the reason. The redistribution is done in the ULS check because there is a material model or stress strain diagram with a plastic branch. So, did I satisfy your answer?
Okay. Strut and tie. Lukáš was a little harsh on that method. So, guys, if there's an engineer who's saying, "I know strut and tie. That's what I like," and you want to explain to him what the strut and tie can do and cannot do, what do you tell them?
Well, it's mainly time consuming, I would say. It's not that tie and strut cannot do certain things. It's mainly time consuming.
Okay.
Yeah.
Your
Well,
idea, Jakub?
I think the problem is that it's only ULS, ultimate limit states, not for the service limit state, because you have you need a cracks calculation, and usually if you have bigger cracks, so usually it's for ULS, so not the SLS, because you cannot calculate the crack weight properly.
It's interesting how popular it is, right?
Yeah.
Okay. We mentioned the design, the checks, the ability to get projects done. How much over-design you guys see in the industry in terms of the rebar design? Joris?
I would think quite a lot. Yeah, because you always have some uncertainties still in your project. So yeah, there's definitely going to be some over-design in there, yeah.
A big one, a small one?
I would guess 20%.
That's interesting. Jakub?
I will say depends on who's the engineer in the particular project is. But it can be 20%, it can be 100%, who knows? It's usually about the structure and the engineer.
And what kind of pressure do you feel to optimize from your customers? And Joris?
Yeah, there's definitely a pressure to optimize because in the end, especially for us, we are specialized in precast concrete, so reinforcement is then the main cost in that product. So yeah, optimization definitely.
Your typical customer is whom? Just so we understand.
We have got multiple customers, but mainly precast factories.
Very good. Jakub?
I don't feel that pressure that much because
As a bridge designer?
as the bridge, it should be there for the Green Deal and the CO2 consumption and everything, but still it's not there that much. It should be. So maybe we will see in the future.
Maybe we're changing that. Okay. Let's look at the questions from the audience. Can we import walls from SAP or ETABS and do the crack width estimation with StatiCa? So that's about the BIM links. So Tomáš, what do you think?
Well, we can't.
Because SAP 2000
Because
doesn't support.
SAP 2000 doesn't support the SAF file.
So SAP doesn't support SAF.
SAP doesn't support SAF. That's correct. That's correct. But maybe Lukáš will answer better about the future of the BIM links.
Yeah, sure. We want to extend the development of the BIM links, so yeah, it will be possible. But what is important to say that the crack width, of course, it is possible to calculate the crack width for every structure model in the detail. So no worries.
So BIM links come in, okay. Is there a theoretical background to what you call stress neglect in the model? That means, I guess, if it is supported by the code. Right. Tomáš?
Well, it is not included in the document we have on our webpage, theoretical background, but kind of informations are written in release notes, and there will be a knowledge base article after the releasing process. Like the article will be transferred from the release
Okay, so
notes.
does the Eurocode support?
Does
that?
the Eurocode support? Yes, it is according to the Eurocode. You can neglect the stress peaks from your calculations.
Next question. Can I use Detail app to check extra loaded pre-stressed beams? Many clients wants to install solar panels on the roofs.
Yeah, actually, it's a great use case. You can do the code check for these roof beams with many openings, maybe depth ends. But very important thing is that the structure has to be loaded just in plane right now, and you are not able to calculate then the stability out of plane. So that's the only let's say thing we are not able to coach it, but everything else we can do.
Is that common, Joris? That everybody's putting huge solar installations on the structure and it's
Definitely.
affecting structurally the...
Yeah. People are adding solar panels to roofs in the Netherlands, making roofs green with plants. So yeah, there's additional loads on existing buildings. Definitely. Yeah.
Very good. Very good. Next question. Can I consider different construction stages of the element in the detail application? Tomáš?
Well, partially. There is no time-dependent analysis in detail, but you can set the coefficient for creep, and you can check 2 times the time without creep coefficient, short term, at the start of the life, and the time with the creep coefficient, and you can set your creep coefficient to time what you need. So it can be end of the life or somewhere in the middle.
Okay.
So you can simulate the time-dependent analysis partially.
Maybe I would say a bit more. This is a tricky question, but in some way it is possible to consider these construction stages, because actually the calculation consists of 3 steps. If you model the structure with pre-stressing, in the first step all the pre-stressing is applied to the calculation. In the second step, all the permanent load is applied to the model, and then in the third step, all the variable load is applied. So then we have, let's say, small time-dependent analysis, but it's not like the normal to do it like that.
Okay. What about cracking, short and long term?
Yeah,
Cracks,
that's what we
yes.
do. That's what we do. So nothing more to say. There are two models for long-term behavior and short-term behavior. We are talking about the stress limitation check, correct with check, and the deflection. So there are two different models, and we are able to co-check these for both terms.
One last question for Tomáš. So if I'm a new user or potential new user of Detail, how can I learn it? Should I do?
Well, that's a nice question. Thank you for that one, because we are just finishing the Concrete campus. Actually, for Detail application, it is on our website, so you can go through it. And for RCS application, it's in the process. It will be there very soon. And if you want, you can order and personalized training from us.
Are the tests hard for the campus course in the Detail?
Well, it's not about if they are hard or not. I hope that these tests will teach you something.
Very good. Guys, thank you very much for participating in this blog. And let's move on to the final block of IDEA Statica Global User Day, the Excellence Awards.